In this lesson, we cover V-Ray IES light. IES light is a photometric light that contains the distribution profile for the light provided by the manufacturers. So basically, using this light type, you can resemble lighting fixtures and produce complex distribution patterns without having to model the fixture or the lamp. So this is the scene we are going to be working with, the same scene we had when we were discussing skylight portal. I've just changed the camera angle and added a few furniture. Before getting into it, one thing I want to mention is that I compose these shots to specifically work with the current topic. So basically, this camera view that we have in the scene is the only one that's going to work. Notice I have these recessed lights in the ceiling, and what we are trying to do is to create our IES lights based on the position of those recessed lights. Now from the V-Ray toolbar, click on V-Ray IES, and in the front view, here is where our first recessed light is located. So let's try to put the light just slightly under the lamp and drag to create its target, basically where the IES light is going to point at. Now select the light and its target, and in the top view, make sure they are right under the recessed light. Select the light itself, and in the modify panel, the first thing you need to do is to define the IES file or that specific distribution pattern of light that you are interested in. So click on this button to define the IES file. You can simply Google IES files and download thousands of free IES files from manufacturers' websites and use a simple software like a photometric viewer to actually see how they look before using them in V-Ray. In this case, I've provided two IES files that you can find in your project files folder, screen assets, and photometric folder. For starters, let's use this complex IES file, which, as the name suggests, it has a bit more complex distribution pattern compared to the simple one that we have here. Perfect. Now let's go to the render settings and change the target to active shade and make sure V-Ray RT is your render, and also lock the view to render to the physical camera 001, and let's start the active shade. First of all, I can select the target and point the light to any direction that I want. Now select the light, and in the modify panel, let's take a look at its parameters. Using enable checkbox, you can turn the light on and off. Using enable viewport shading, you can see the effect of the light in the viewport if a higher quality viewport is activated, obviously. Next we have show distribution, and when enabled you can see this mesh around the light that represents the distribution profile for this particular IES file. Next we have targeted, which allows the light to have a target to make pointing the light at a specific direction easier, and we used it a few moments ago. Then we have IES file, where we can define that particular IES file that we want to work with. Next we have rotation X, Y, and Z, and we can simply rotate the light in different directions using these values here. So let's try rotating the light on X by 5-degree increments. Also, you can use negative values here. Let's try Y rotation. Now in this case, Z rotation or Z direction wouldn't do much. Then we have cutoff, which is a threshold below which V-Ray stops computing the light. Let's try 0.4. Now let me set it back to its default value of 0.001. Now let's stop the active shade and let's change the IES file to the simple one. Also in the render settings, let's untick override material and run the RT again. Shadow bias move the shadows produced by this light away or towards the shadow casting objects. Then there is cast shadow, which allows you to enable or disable shadow casting for the light. Next we have affect diffuse and diffuse contribution, which controls whether the light affects the diffuse portion of the materials or not, and by how much. Then there is affect specular and specular contribution that lets you decide whether the light affects specular reflections and basically by how much also. Now let me enable override material again to get faster feedback. We have use light shape. Here we can decide on how the shape of the light is going to affect our shadows and illumination. If set to no, you can see we get very sharp shadows, and that is because when set to no, V-Ray considers the light to be a point light. And as we learned earlier, the smaller the light source, the sharper the shadows, and that's why we get these very sharp shadows in the scene. If I set it to for shadows only, the shape of the light indeed affects the shadows, and as we can see, we get diffuser shadows, but the overall illumination will not be affected. And if set to for illumination and shadows, the shape of the light will affect both the shadows and the overall illumination. Let's set it to for shadows only. Next we have override shape, and if enabled, the original shape of the light will be ignored and you can specify other shapes to be used. Now remember, these shapes won't affect the light distribution, it just changes the way our IES light handles the shadows and overall illumination. Let me change the shape maybe to a sphere. Now if I set the diameter to something like 1, the shadows will be very sharp, and as I increase its diameter, the shadows are getting diffuser. You can use different shapes, and height, width, length, and diameter parameters can be used to control the exact dimensions of your specified shape. Here let me change the shape to point and disable override shape. Next we have shadow subdiv. As you increase it, you're going to get higher quality shadows, but it also depends on your image sampler and global DMC settings that we are going to discuss it later on. Then we have color mode, and it works like normal V-Ray lights, right? Next we have intensity type, which is the unit to control the light's brightness. We have power that controls the intensity of the light in lumens, and intensity that controls it in candelas. So let me set it back to lumens here. We have intensity value. Obviously this controls the overall intensity or brightness of the light. Let me set it back to 4850, which is the default intensity for this particular IES file. Then we have area speculars. If you disable it, the IES light will be seen as a point light in the reflections of our materials. The rest of the options are having the same functionality as other V-Ray lights, and we discussed them in previous lessons. Now let's go ahead and finish the lighting of the scene and prepare the scene for the final render. Stop active shade and close any active window. Select the IES light and its target. Start copying the light and its target to other recessed lights that we have in the scene, and make sure you set the mode to instance, so altering one light would affect the rest. Now, as you can see, I didn't cover the entire room. That's because, as I mentioned at the beginning of this lesson, I'm composing and lighting my shots for the specific camera that I have here. But if you like, you can go ahead and add more lights to the rest of the scene and maybe add more furniture and render other angles. Open up the render settings and enable override material. Now let's run RT and see what we have. Perfect. Let me stop the render here. That is a good starting point. Now I'm gonna add a few area lights to the scene to make the lighting a bit more realistic. So let me select Den Vray sphere light in the toolbar. And in the top view, let's add the light. Now move it up in the front view. Create 2 copies from this light and distribute them in the room. Now select one of the lights and change its radius to 15 centimeters. Set the unit to watts and change the multiplier to 25. Also set the mode to temperature and use 5000 as the volume. Now let's run the active shade again and see what we have. If I turn these sphere lights on and off, you can see how they affect the lighting. Now in V-Ray we have a material called V-Ray Light material. We discussed V-Ray Mesh Light a few lessons back, and when you apply V-Ray Light material to a specific object, it turns that object to a self-illuminated surface. So let's create a V-Ray Light material and apply it to our recessed lights as well. In the material editor, right click and add a V-Ray Light material. Set its multiplier to 10 and enable direct illumination. Now I have renamed the parts of the light that I want to apply this V-Ray material to light MTL, just so I can be able to select them easier. So type light MTL in the Explorer and press enter to select them. Now assign the material. Also, if I open up my environments and effects window, as you can see, I have this gradient ramp as the environment map, and if I instance it in the material editor, you can see it's a very simple map. Now let's make sure the override material is disabled in the V-Ray RT settings, and let's run the active shade again. Okay, perfect. Also, I think the scene is a bit dark, so let me select my camera and reduce the exposure value by 1 stop, so the camera would let a bit more light in. Now, perfect, that's a lot better. Let me stop the active shade and let's enable lens effects in our frame buffer before the final render. Now let's open up our render settings window, change the target to production rendering mode, and in the common tab use 1200 and 1600 for width and height. In the view array tab, change the max subdiff to 50 and noise thresholds to 0.008. Also, let's make sure local subdiffs is turned off. Now in the GI tab, set the irradiance map preset to medium, set the subdiffs to 70 and samples to 25. And in the light cache, increase the subdiffs to 1000. Also, let's add V-Ray denoiser in the render elements and change its preset to mild. Now we can go ahead and start the render. Now in the frame buffer, this is our final render. Let me make sure bloom and glare effects are off. Open up the corrections control. Let me enable curve correction and maybe add some contrast. Finally, let's enable bloom and set its weight to 4 and height to 20. Also enable glare, set the size to 10 and weight to 20. Also, this is our denoise version of the render. Now you can save these renders out and you are good to go, and maybe color correct them in Photoshop if you like. So in this lesson we learned about V-Ray IES light, and I will see you in the next lesson.